Hello children, today we are going to learn permutations and combinations. Here we will discuss the basics and the formulas of permutation and combinations. But before that, the first thing which we need to learn is factorial. Now, what is a factorial? Factorial is an operator and we defined it for a natural number n factorial n, which can be written like this or also can be written like this, factorial n, which is equals to multiplication of n consecutive natural numbers. That means when I am writing factorial n, this is equals to n into n minus 1 into n minus 2 into so and so 3 into 2 into 1. That means when you are writing factorial 5, this is actually equals to 5 into 4 into 3 into 2 into 1. Now one thing must be clear from there, that 5 into 4 into 3 into 2 into 1 can be written as factorial 4. It can also be written as 5 into 4 into factorial 3 and so on. So the formula which you are going to get from here says factorial n is equals to n into factorial n minus 1, which can be used whenever it is required. Now let us understand permutation and combination. But before that, again we need to understand one very important thing, which is called fundamental theorem of counting. Let us understand it in a very simple words. It says that whenever you are using the word and, you are going to use multiplication, and whenever you are going to use word or, you will operator addition. It will be more clear when we'll be talking and discussing the questions of permutation and combination. So right now we can just think that whenever the word and is used, I'll be using multiplication, and whenever there is or, I'll be using addition. Now let us understand permutation. The meaning of permutation is arrangement. When we take few objects from the given objects and then we are going to arrange them, and now since we are arranging, order matters. That time we are talking about permutation. Like if there are n objects, out of n I have to select r objects and I need to arrange them, not only selecting, arranging also. And since I'm in the arrangement, that's why the order matters. That means AB and BA are two different arrangements. That time we are in permutation. So selecting r objects out of n objects and arranging them is denoted by NPR. It is also written as P of n comma r, and this is defined as factorial n upon factorial n minus r. Factorial n upon factorial n minus r. Now here, if we find out that the r objects which we have taken, out of which there are few objects which are repeating itself, like suppose out of n objects we have to select r objects, but from the r objects we have few objects are coming for p time, few are coming for q times, and few are repeating itself for suppose s time. That time we want to find out NPR should be equals to factorial n upon factorial p into factorial q into factorial r. It was permutation. But if I want to talk about combination, combination is just like permutation, and the difference is that here we are not arranging the articles, we are just selecting them. So here order does not matter. So when I am selecting R objects from the N objects, that time we denote it by NCR, and NCR, which can also be written as C of N comma R, is factorial N upon factorial N minus R into factorial R. And why we are doing this factorial R? Because the extra selection which you have taken for different order, that should be removed. So here factorial N upon factorial N minus R into factorial R, that will be combination. So the basic difference between permutation and combination is that in the combination we just do the selection, but in the permutation we select the articles and after that we arrange them. In permutation, order matters, but in combination, order does not matter. So this is the basic difference between permutation and combination. Now there are few properties of combination which we use for solving the different types of questions. The first property which we can use for combination is NCR is equals to NCN minus R. The second property which we use is if NCX is equals to NCY, that implies either x equals to y or x plus y is equals to n. There's one more property which we make a lot of use, which says that NCR plus NCR minus 1 is equals to n plus 1 CR. So for solving different types of questions, we make the lot of use of these properties. Now here what we need to keep in our mind, that whenever there is a question of only selection and the order does not matter, that time we are using combination. But when the order matters and we are doing arrangement, that time we are in permutation. Again, when there is the situation of word and, we need to use multiplication. But whenever there is a word or, that time we have to use addition. I will try to explain the fundamental theorem of counting by a simple question of combination. Like I want to find out or select 4 cards out of a pack of 52 cards. I want to select 4 cards out of a pack of 52 cards such that all the 4 cards must be from the same suit. Now we know it very well that in a pack of 52 cards there are total 4 suits, and I want my all 4 cards must be from the same suit. That means first of all I will take all 4 cards from the first suit, and that can be done by 52C4 which can be done by 13C4 ways. Or I can take out the 4 cards from the second suit, that can be done by 13C4 methods. Again, I got another option to take 4 cards from the third suit, or I can select the 4 cards from the last suit. So I can see that whenever I am using the word or, I am using addition, because for selecting 4 cards I had 4 options. There were 4 suits and the 4 cards could have been selected from any of the suits. So there was the word or, that's why I have used addition. Now if instead of this I say that I want to select 4 cards from a pack of 52 cards such that each card should be from the different suit, that means I have to select the first card from the first suit, and I have to select the second card from the second suit, and I have to select the third card from the third suit, and I have to select the fourth card from the fourth suit. So in this way I have found all 4 cards from the different suit. So the answer will become 13C1 raised to power 4, whereas here the answer was 4 into 13C4. So when I wanted all 4 cards from the same suit, the answer comes this. But when I want each card from the different suit, the answer comes this. So here the difference of addition and multiplication is very much clear, and the fundamental theorem of counting can be understood. Thank you, children.